Hi all, welcome to the video. In the last video related to isolation forest, we had discussed what are the important requirements of running the model, right? So the thing is, there was one package that I forgot to mention, which was RCPP, and it is very essential. If you don't have this package, immediately install it before going about training your isolation forest model. Now the thing is, we'll basically look at a dummy data set that is available in an R package, and we'll then try to train an isolation forest on it and see what the results look like through a visualization. Now the first thing is to basically install all the packages. Now the packages, let's say, or better yet, just a second, installation of packages. I can maybe leverage some of the links that I already have. Oh, there is no internet. Okay, no problem. So there are few packages that I would like to use, one of which is deployer and the other is, I think, ML bench. Yes, okay. Then we have RCPP. I think then we will have yeah, the package for training an isolation forest model is basically available with Solitude. So we will install Solitude, and then just for dimension reduction we will use what just to create pretty tables, pretty output tables. We will be using table this time, and then to finally visualize the result we will be using ggplot. Okay, so we have installed all the required packages. Now let's look at the dummy data set. So this is the diabetes data set available from ML branch. And this let me check my diabetes. Okay, so you see I have basically I have used this data set and I have imported that into the environment. And if you want to look at how exactly the top few records look like, I can just go to the environment window and I can just click on it. If you see a quick description of the data set, so these are at a patient level or at a respondent level, and these are indicators for each respondent. I mean, whether how many months is the lady pregnant, what is the glucose level, pressure level, and so on, along with age. And then finally we have an indicator or an output variable in the form of diabetes. It is basically positive, negative. So what we are going to do here is, first we will convert, or we will split the data set into test and train, and then we'll first remove the diabetes column so that we don't have an output indicator. In that sense, it becomes an unsupervised machine learning problem. Then we'll train an isolation forest on this particular data set and then we'll basically see what exactly does the visualization look like. So let's, sorry. So first let's, just a second. So let's, sorry. Where is it? Okay. So let's convert the data set into table and split into train and test. Okay. So let me do a DA. Let me say, let's call it diabetes underscore TF. And yeah, just let me correct the spelling. And I will do as underscore table. Okay. Okay, so we have a diabetes data set. If I just look, if I double click, you will see it's mostly close to, I mean, data.table in terms of look and feel. Yeah, so that's the only advantage of using table. And then let's divide it into train and test. So we can basically do that using setting up a seed first. Okay, and we have to also remove diabetes so that it becomes an unsupervised problem. Okay. Sorry. And I will basically remove it. Okay. So now my DF doesn't have any diabetes column, and now I will basically create two cuts of the dataset, one for training the dataset and then the other for testing the dataset. So I will basically sample the number of rows in DF, and in my training dataset I will have 70% of the number of records in the original dataset. Okay, so and I don't want to replace, I basically want to, don't want replacement in my sampling. Okay, so train.tf is equal to, what's happening? Okay, yeah, train.sample. Okay, so if you see, my train.df has been created with 537 observation. Let me take that as it is, and let me do a 30% sampling. Let me just rename it test. Okay, so my train and test datasets have been created. Now I will basically be training an isolation forest model. And just to tell you how quick the model is, let's record the time. Sys.time. Okay, and we first have to create an ISO object, and this can be created using isolation. Okay, isolation forest, and we basically want to create a new object. Okay, now the first thing that we want to specify is the sample. We want to specify the sample size, which is nothing but n number of rows in train.df. Okay, and I think I have initialized it incorrectly. I think it is calling from some other library. Actually, oh yeah, now it is correct. Now basically we also want to specify the number of trees. Okay, let's use what, 10 just for example, and then the depth to which the branching will be done for each individual trees within the forest. So I mean, let's use a ceiling function, and normally log of the number of rows in the train dataset. Okay, so if I, and once that ISO object is created, okay, and then let's ISO fit, and I will basically fit the model on a train data frame, and let's look at the number of seconds or number of minutes it takes. Okay, so let's now train this model. Okay, it trains in like half a second, but yeah, this particular piece of code would give you an idea as to what will be the amount of time taken to actually train the model, and it's pretty fast. Isolation forest, it has been designed in such a way that it computes very rapidly. Okay, now so the thing is, just a second, I think the video is running a bit longer. Let's look at this in the next video.